Assalamualaikum. We are from the group D. We present about shallow and deep foundation, and our slogan is a vision of a better building. So these are our group members. Start with me, AMIRUL Aiman bin Rio Henry, followed by HAIQAL bin Mazlan, then NUUR Muhammad AHNAF bin Samar, and lastly Muhammad NURUDDIN bin Shahrum. Our organizational structure start with Muhammad as a chief, and he in charge in deep foundation, then followed by HAIQAL, and he in charge in shallow foundation and isolated foundation. Then me, Amirul Aiman, which in charge in introduction and also definition and characteristic. And lastly, Muhammad Nuruddin, which in charge in future foundation. Then we go to the definition. First, shallow foundation. Shallow foundation are those that are built near the earth's surface or that transfer loads at a shallow depth. Deep foundation refers to a foundation that is buried deeper or distributes load to a deeper strata. Then we go to their characteristic. First aspect that we consider is feasibility. The shallow foundation is easier to construct while deep foundation has more complex process. Next, mechanism of load transfer for shallow foundation is transfer loads mostly by end bearing, while for deep foundation is rely both on end bearing and skin friction with few exceptions like end bearing pile. Then the depth for shallow foundation is 3 meters or the depth of foundation is less than the footing width, while for deep foundation the depth is greater than the shallow foundation. The depth of shallow foundation is cheaper compared with the cost of deep foundation, which is more expensive.
The definition of the pile foundations are deep foundations that are formed by a long, slender, columnar elements typically made from strong material such as steel or reinforced concrete or sometimes timber. A foundation is described as a pile when its depth is more than 3 times its breadth, as it's inserted into the ground to transmit loads to a lower of subsoil. Pile foundations also are usually used for large structures and in situations where the soil at shallow depth is not suitable to resist excessive settlement, resist uplift, or soil with a high bearing capacity. Firstly, the types of situations or we can set where to use the pile foundations. The first one is the groundwater table is high. The moisture of the soil is high and must a strong foundation to support the buildings. The second one is the soil at the shallow depth is compressible. So we have to drill the foundation on the depth from the ground level. The next one, there is a canal or deep drainage system near the structure. Other types of foundation are costlier or not feasible. So we have no solution on probability using another foundation on facing construction area problem. The types of the pilings based on the function of pilings. The first one is sheet piles. These types of pile is mostly used to provide lateral support. Usually, they resist lateral pressure from loose soil, flow of water and another problems. Next, load-bearing pile. These types of pile foundation is mainly used to transfer the vertical loads from the structure to the soils. These foundations transmit load through the soil with poles supporting properly onto a layer which is capable of bearing the load. The next one is the end-bearing piles. In these types of piles, the loads pass through the lower tips of piles. The bottom end of the pile rests on a strong layer of soil or rock. The friction piles transfer the loads from the structure to the soil by friction between the surface of the pile and the soil surrounding the piles, such as stiff clay, sandy coils. Generally, the entire surface of the piles works to transfer the loads from the structure to the soil. The next one is the soil compactor piles. Sometimes piles are driven at placed close intervals to increase the bearing capacity of soil compacting. Move on to the types based on materials. The first one is timber piles. It lasts for approximately about 30 years. It can be rectangular or circular in shape. concrete piles provide high resistance to chemical and biological cracks and usually built from a high strength. Next one is steel piles. Use the small section area. The piles are easy to drive. They are mostly used as end bearing piles, so it's easy to install. Last one is the composite piles. Piles of two different materials are driven and over the other so as to enable them to act together to perform the function as a single piles. From the sustainable elements, the environment, the works of pile is very neat and clean. The second one is a complete avoidance of digs excavations. Next one is the piles can be pre-made its length, breadth, its size according to site use. The next one is the best for the wetland area because aware of the fact that wetlands are very hard to handle or work with. So for the social, the first one is the safety of workers is guaranteed as working over water, as is the case with piles in jetties and wharf structures is have a strong structure. And the second one is not disturbing neighborhoods area as its noise level is too low by using driving concrete piles. For the economy, we can use piles in a place where drilling and holes are not done, so it will reduce the cost on the drilling again. Next one, the payout for the large machinery and trained laborers to operate it can avoid. Its things can achieve by using screw file foundations. Next one is the piles are comfortably handled and cut as much as you want by using the steel piles, so it's easier, not depends on the budgets on the certain size. The piles also can carry heavy loads easily. Next one can be installed in a very large area. The last one is very inexpensive for timber piles because timber is abundant, hence these piles are economical.
Hello, my name is HAIQAL and my part is current shallow foundation. The example for current shallow foundation that I choose is isolated footing. What is isolated footing? Isolated footing is structural component that are used to transfer and distribute loads from single column to the earth, and it is installed separately under a single column. Isolated footing is built to avoid excessive settlement and offer enough protection against sliding and overturning. Isolated footing come in variety shape and sizes. There are several types of isolated foundation that is commonly used in structural building. First, pad footing, step footing and slope footing. First, we talk about pad footing. Pad footing is the most common shallow foundation you will meet in any building construction. This is commonly come in rectangular and circular shape, and this pad footing help lessen bending moment and shear force at important point. Maybe someone wonders how actually the pad footing look. So this is the picture of the pad footing. The second type of footing is stepped footing. Stepped footing keep the metal column away from direct contact with soil. Three concrete cross section are typically piled on top of each other and primarily used in residential building construction. This is how stepped footing looks like. The last common isolated foundation that we will discuss is slope footing. This type of foundation designed and built to maintain a 45-degree tube slope on all sides. And this type of foundation reduce use of concrete and reinforcement. So, when the concrete and reinforcement use reduce, it also decrease the utilization of concrete and reinforcement. Slope footing usually used in inclined surface construction. This is how it looks on construction site. As I mentioned before on the previous slide, there is several types of isolated footing. First is square, then rectangular and circular footing. Next, we will discuss about the sustainable element in terms of environmental. The first point is large excavation not need to perform or construct this structure so it can save more space and not disturb the environment around the site. Second point is less drilling is needed because it's only shallow type of foundation as it's not produce much waste, sound and air pollution. Next sustainable element in terms of economy is it is very cost-effective foundation as the type of footing use less amount of reinforcement and concrete and also less machine use, so the cost can be reduced. Last sustainable element in terms of social is first, the design of isolated footing is simple to build and not heavy duty as the construction does not need much energy and even unskilled or professional workers can construct it. Second point is foundation hold the structure's load, making the structure strong enough for people and also provide safety for the user. That's all from me. Thank you.
Hi, my name is NURUDDIN. Next, I will talk about the future deep and shallow foundation. Okay, next for deep foundation, I think micro piles is the future for deep foundation. It is also known as mini piles. This type of piling are elements constructed with high quality, durable, small diameter steel casing or treated bar. Micropile itself will help to underpin the foundation, minimize foundation settlement, and it is the best option when installing in area with difficult soil makeup. Micropile have many benefits. Some of them are it is most practical and cost efficient solution. It can easily be installed due to its compact, lightweight nature and ideal for confined or remote area. It can be installed at any angle and also can withstand axial and lateral load. Lastly, this process can reduce the time of installation compared to other type of deep foundations. For shallow foundation, I think industrialized building system is the best option for future foundation. Although it is not widely used yet, but I think it is the best option we can use for future shallow foundation. IBS is a technical way of describing the construction of a building fitting together pre-constructed parts made in a factory. It can produce better construction quality and productivity while reducing the risk related to occupation safety and health. This system also can mitigating issues for skilled worker, reliance on manual unfamiliar work. There are 5 types of IBS used in Malaysia. First is precast concrete system. Second, steel framing system. Third, steel formwork system. Fourth, timber framing system. And lastly, blockwork system. The benefits if we use IBS for foundation. First, it is cost saving. It can reduce construction wastage. Second, it shortens the production time. The production of IBS component start during pre-construction period. Next, quality building. We will only use high quality component. And lastly, safe working environment. Because IBS is like assembly type operation. Conclusion, deep and shallow foundation is very important because if the soil at the construction site is not strong, the building that we construct may damage or collapse. As civil engineer, we need to think of how we can improve the foundation in the future. Thank you.